Let's start with company update.
I just noticed that test gem no longer actually tests a gem because the contiguous is being ignored. But that's not really company related. I just noticed this. I'm like, why is this happening? Sales are good. We sold a lot of tiny boxes. We made like another 200K in wires last week. I don't know. Everything just feels slow as usual. But I don't really know who's making faster progress on this stuff. It seems like we live in a world where this like agentic coding crap has elevated the temperature of everything to some crazy high point, and then like you look at what's actually been produced. Like, can you name a software project that's been produced since like December when this all started? And like, not really. So yeah, it's all slow going, but maybe it just feels slow going. That's how this is the whole like the trick of AI. It's like you don't know if am I being reward hacked? Um so yeah, no, I think we're proceeding toward a spec. A lot of things basically look like proceeding toward a spec. If what you're working on doesn't look like proceeding toward a spec, then we should fix that. Because that's kind of like okay, we're gonna have mix-ins as an isolated thing. We're gonna have the program spec as an isolated thing. We're gonna have a Rangeify spec that figures out how to remove these e-kernels. We're gonna have a set of tests that are well thought out, and we're gonna do the llama contract. To prove that we can actually like do something, and it's like touching grass, right? I think it's more important than ever to stay in contact with reality, and reality is training large LLMs. So yeah, that's the company update.
Sounds good. I think in the emergency he's traveling, so he puts the updates in HCQ drivers. I think there was added just support and something is still missing.
Yeah, it seems like it's coming along nicely. You said profiling's missing. Yeah, I mean there's going to be a whole set of cleanups to HCQ2 as well, but at least the first step is just making it visible to the UOP graph, like making it like legible. Like we make it legible to the UOP graph, and then we clean it up. Like get adder, is that real? I don't really know. What does that do? But yeah, no, we should have him. If he was here, my advice would be I'll just post this in HTTP drivers. I'm like, can you add all the new UOPs you are using to the spec?
Our spec document.
Yeah. It's pretty complete now. At least for like all the code stuff actually matches the spec now. Like everything that's going into the renderers is now fully in the spec.
Right.
And I think we can also remove barrier. I think barrier is just after local.
Okay. Anyway, I think that's it for HCQ, and we can move on.
Yeah. So I looked into putting everything into a Docker. The smallest I got the Docker down to was 3 gigs, which seems a little bit big. So I didn't end up moving that.
What are in those 3 gigs?
So a lot of it is the Intel OpenCL CPU runtime that we use. I looked into whether or not we can compile it ourselves, but I think it's closed source. I don't know. Like it looks like they tried to open source it at one point and then gave up on it, I guess. So now it's now it's still closed source.
Is there a different
Um,
runtime?
I looked into Rustical, which is Mesa's. Like you could use a Mesa OpenGL backend as your CL runtime, but that seg faults in the compiler, so it doesn't seem like a good. So there's also portable OpenCL or POCL, but that one
Yeah, I think we
also
used to
seems
use
have
that.
it seems to have issues as well. Like it doesn't support a lot of stuff, or it claims to support. I think it's FP16. It claims to support, but then when you actually try and do anything in FP16, it crashes.
Yeah. Wow, I didn't know this
I
wasn't
don't
open
know.
source either.
Yeah, like when you Google it, there's actually a Phoronix article that says like, oh, they're open sourcing it, and then you click on the link, and it's to a PR that has no history and didn't get merged.
Yeah, I mean, ChatGPT says, yeah, it's not open. Yeah.
So I don't know. The other thing is that we end up installing LLVM like many different times. Like so, obviously, Co-Manager has its own build of LLVM, and then we install LLVM as well. And then, unfortunately, I made it so the GPU Ocelot no longer depends on LLVM, so we don't have another copy of LLVM there. But I think that also is a big
Yeah,
contributor to why the size is so big. Is just because we have like many different copies of LLVM lying around.
should only be like 50 megs. LVM's not that big.
Yeah, I don't know. I mean, yeah, that's true. But I guess it all adds up.
Yeah. How bad is a 3 gig Docker? How slow is that?
So I didn't try downloading it. So there's also this kind of question of like, okay, so you how do you want to build the image? So what you could do is you could build it on master, and then upload it to GitHub container registry or and then every time like some PR runs, it downloads from master the Docker image. But that's a little bit frustrating because then it's like, okay, well, if you, I don't know, say we want to bump the LLVM version because we depend on some new feature from LLVM 21, then you need to have one PR that updates the LLVM version, and then the next PR that actually, depends on the change that you made.
I'm totally fine with that, but I think the bigger problem is just how long does it take to download 3 gigs? 3 gigs is a lot.
Yeah, well, so fortunately, actually, you don't have to download 3 gigs. You only have to download 700 megabytes. So I should test that out. I should see how slow it is. But yeah, it does
Yeah, I
keep
mean,
crashing stuff. So
I think we should just see how slow it is and see like how long because I want these CI jobs to be short, and I don't want to spend more than say 10 seconds setting it up.
yeah. When I was looking at this, like there are definitely some that are slower, but on average, seems like around like 15 seconds. So that's why I hadn't done that yet. But I'll check and see how much faster it is to just download instead.
And then for the Intel thing, I know it like downloads a ton of crap. Like, do you just need it all, or can we just delete files?
The problem was that we installed from apt because we can't just build it ourselves. I guess I could probably just like pull out the binaries and see if we can just
That's what
from the apt package.
saying.
Yeah,
Is it like 2 SO files that we need? Like,
I'll have to check. My understanding is that like it also installs the compiler, and that's a separate thing, and then it also installs thread building blocks, which is like Intel's replacement for OpenMP. But I don't know. I will test that out and see if I can just pull out the SO files that we need.
I bet it's 2 SO files. Yeah.
Can you also comment on what are the slow jobs now and what are the flaky ones?
Yeah, so some of the slowness, especially in the install, like the setup tinygrad step, is even though we're using UV, which did speed up some stuff, whenever we have to install like the full testing, like tinygrad brackets testing, that takes a while to install. And I think that's mostly in installing stuff like TensorFlow or installing Onyx. Those both seem to be super slow to install.
What do we
And
still use
then
TensorFlow for?
we use TensorFlow to test Lars.
I think we should just replace that with something else,
Yeah.
or just not even test it. Like, should Keras.
Yeah.
This isn't worth installing TensorFlow over.
Yeah, that's probably true. And then the slowest stuff that's on Linux right now is OpenCL, which I think that just the runtime is just slow. Like whether it's the compilation or the runtime or whatever is slow, something's just slow about that. Because I went through and I like tried to get rid of a lot of the most egregious stuff, but it still takes 2 minutes and 30 seconds to run all the OpenCL tests. Without there being like one obvious thing that's like, oh, this test takes like a full minute to run or something like that. And then the macOS tests are just slow too. And I think what I need to do for that is I just need to say like, okay, we're gonna put that near the same level of Windows support. The only issue there is that we really don't want to have the benchmarks where we run PyTests. Well, I mean, we don't want macOS to fail, but also we especially don't want PyTest on macOS to start failing because we didn't adequately test something.
So I don't think macOS is like Windows, because I think testing metal is really important, right? So you basically have to run whatever your full backend tests are, no matter what, and it's all going to run in parallel. So it's not like it's going to be like slow.
Yeah, it's true.
So yeah, no, I mean, I think we just need to. There's not like a thing that we can do like what we did for Windows. I think we just have to like actually reduce the surface area that we feel, that we have to test on the back end.
Yeah. I mean, the slowest macOS stuff right now is like the macOS unit and macOS or metal models. I think those are the two slowest things.
Yeah.
But yeah, I mean, in theory, yeah. Like, so I guess WebGPU is actually different on macOS because it uses that metal backend. But in theory, any differences there are kind of down to the WebGPU runtime, not down to.
I would download all the logs and stick them in GPT and like just have a conversation about what the surface area actually needs to be. Yeah. Like all the historical failures give you a lot of data points on this.
Yeah, that's true. That's true. Yeah, that's a good. I should put that into ChatGPT. I hadn't done that.
Why is the CL flaky?
Yeah, so I looked into that. That also it's hard for me to tell because I can't reproduce it locally. I tried running that a couple of times or more than a couple of times. I tried running that I ran it successfully 200 times, like with the same parallelism constraints with the same runtime locally, and never saw that failure. So I'm not entirely sure, but looks like there's two failure modes. Both of them are some sort of seg fault. And in one case, it seg faults in some like background thread that Python's not aware of. So the nice thing about fault handler obviously prints all the threads, but it only prints threads that it's aware of that like are Python threads. And then if there's another thread that was spawned by so for instance we call it to the OpenCL runtime and then it spawns a thread. Then if that spawned thread crashes, then we just know that it crashed. We don't know anything about it.
Can you enable core dumps?
Yeah, I'll look at. Yeah, that should be possible. And then there's also a different failure mode where it crashes in the compiler, and I have not explored. I'm not entirely sure. Some of the most recent failures that we had in CI failures were because the compiler crashed.
Are we sure it's not out of memory? Right, like most of these things are usually out of memory. Can manifest in so many different ways.
Yeah, I'm pretty sure it's not. I haven't checked all of these, but the last couple of times that I checked these, when you look at the memory graph and namespace, it doesn't show that it's out of memory.
And it might be.
Oh, okay. So this one is running on GitHub runners, so that's not. We don't know if it ran out of memory, but it seems likely to me that it didn't run out of memory because it's the GitHub runners have more memory than the namespace runners.
Because I just had one failure in my latest PR 16613 and 04 CL related saying fail at the same time. So that's kind of weird, assuming it's like running in good isolation. And it's like
Yeah.
output value or not. I mean, one of the job crashed, but every other thing when is like a value mismatch. So I don't really know what's happening, and of course it finished
Yeah.
fully after
So I've
the
seen that
run.
before, but I think it's just once something in the runtime crashes, then the outputs are just completely unreliable.
So this is like CI setup issue.
I mean, I don't know. I mean, you could reinitialize the runtime every time for every runner, but that would just make it really slow.
Okay.
I'm not sure that I feel like the right thing is to figure out what the actual bug is here, but
I mean, that makes sense. If we can find, if we can root cause it properly and fix it, that would be nice.
yeah.
Okay.
Yeah.
Okay.
I don't know if there's anything else. That's kind of it. I added or I split apart the comma tests or the comma benchmark. And the DSP, since we barely run anything on comma fours right now, I moved the DSP benchmark to comma four.
Oh, I didn't realize they were different. We might want to look into Pockle, even if it doesn't support FP16.
Mm.
I don't know. I always
Yeah.
hated that Intel thing anyway. And if it's causing trouble, I just, you know, my thoughts on Intel.
Yeah. Yep. No, I will spend some time looking into Pockle and re-looking into Rustical as well. I think Rustical could be a good
Like
option because that seems much more modern.
maybe it generates the wrong output if you're running it on an AMD CPU.
Yeah, when you Google this is what all of the Intel forums say. Is they're like, well, you're running on an AMD CPU. That's
No,
that's not
they're
good.
clowns. I mean, they're just such clowns as a company. I think I don't know how developed Rustical is, and there's always people who try it. If the only problem with Pockle is FP16, I think we just switch to that and
I
not
think it's
test
also slow.
FP16.
I think that's
Yeah, but there's also options for it. I bet it can be made fast,
all right. I
like with
will.
like
Yeah, I'll look
flags.
at it.
Yeah,
Yeah, I'll look at that, and I'll also look at downloading that Docker image and seeing how bad it
yeah.
is.
But no, I mean, it really wouldn't surprise me if that wrong output is due to a bug in the Intel OpenCL compiler if you have AVX2 but not AVX 512 or whatever.
Yeah. Yeah. I'm not sure.
Okay. Next, I put two llama stuff together, and we will start with parrot.
So I merged MXFP8 gem. This helps DP convergence a bit, actually. DP convergence is consistently a bit faster. This doesn't really help MP convergence. There's something else that's bugged with MP that I'm still tracking down. That causes MP to not converge in the right amount of steps.
Do you think it's a bug or
So
numeric?
it's really hard to tell if it's a bug or if it's numeric. There was a bug there's the rand bug. So I hit the rand bug, where two of the weights were the exact same in it.
Yeah.
And I fixed that. I worked around that, and it doesn't seem to really change convergence. I don't really expect that to change convergence much, but it does make diffing between DP and MP easier.
How many steps slower is it?
MP is about 300 steps slower.
Do you have some links to these?
This is AB.
This is 8B, yeah.
Across how many GPUs?
8.
Can you start with 2 and see if that's better? Because it can also be other issues.
Yeah.
And I think previously, maybe you are already doing this, but like just logging some stats to your gradients help previously.
Yeah, I mean, I can pretty easily tell very early in the run if the run will converge just by looking at grad norm.
Yeah, at least so too, right? And I think previously what helped me also was just log the max of the grade also help. Because if that goes really bad, you can see that.
Yeah,
And
that's probably useful.
and I think maybe just try 2 GPU to start with, because all the overages and things, and I would be really surprised if 2 performs very different from like 1.
Yeah.
Yeah, Indian bug is really bad. I don't know.
It's just
Uh,
really hard
do,
to track down where it's diverging.
do we use dropout? Do we use batch norm?
No dropout and no batch norm.
And that's usually whenever you see differences, it's usually those two things. But I don't know, like the problem with all the tiny D types is numeric stability can
Yeah, I mean, it's always
be
something
really.
numerical.
Have you tried no up?
I've not tried no.
Yeah, I don't know if that's gonna. So how close are we to getting 70B to train and work?
It's unclear. I hope to have something by the end of this week, like at least kick off a 70B run again.
So we've switched. We're using MXFP8 on the
For MP, yes.
not for DP.
Not for DP. It's slower. The kernel's slower.
Well, I mean that could be the difference.
I've also done DP runs with MXFP8, and I'm comparing against that run.
How much slower is it?
There is a faster kernel I can pull. There's one other kernel that worked, but this kernel, at least for MP, which was already pretty slow, this is about another like 3 seconds slower.
Like that's crazy. So you mean like the 14 seconds should be like 11 seconds if we had the right kernel? Where'd you get this kernel?
Hipkiddin's just merged MXFP8 stuff in like the past 3 months.
Let's see. What did the reference AMD 8B use?
Reference 8E is DP sharded.
I know it's DP, but did they use MXFP8 or did they use single?
They use FP8, not MX.
Okay.
You don't really need MXFP8 at 8B scale.
Yeah. Okay, but no. So there's not like there's no AMD run on the board that uses MXFP8.
No. Because no one has really trained anything big enough on AMD yet to warrant.
Yeah. How quickly can you see the issue in the grad norms?
Within the first 100 steps.
So in the first 100. And what do they look like on the bad ones?
The grad norm never settles to. So if you look at the runs I posted, they settle to like 0.2, and then on bad runs, like this one, it
Well, I don't
does
see it go to
settle.
0.2 for a long time.
But it will settle much lower than.
You have a bad one?
I don't know. I looked at that last meeting, like it looks the same to me.
I generally can tell. Like the initial spike also isn't
Oh, yeah.
correct.
This looks much bigger.
Yeah.
Probably should change this graph to log scale.
Wait, but
There.
they all have the same, and they all have the same initial spike. I mean, I'm just looking at the log. I'm looking at.
Yeah, it spikes at different place, which seems to matter a lot.
It looks almost the same to me.
It like spikes
Oh,
one
okay.
step late.
Yeah. One step is. I mean, should we have this spike at all? This initial spike just seems bad. Period.
So on runs without the initial spike, it doesn't convert at all.
Really.
It's very odd.
I mean, I don't know. This looks like reading tea leaves. I can't obviously see what's wrong with the other one. What precision are you doing the all reduce in?
BF16.
Is that okay?
I've tried FP32 as well. Doesn't seem to make a difference. Yeah, I think there's just like at least a minor thing.
What happens if you just try for a 7 dB run?
It'll just take a while, like a really long time. Yeah, I could try
I
for
mean,
some run.
this whole thing is so slow. Why is it taking a day to do this?
So it's 6 seconds for Optim. Optim is just really slow on the CPU. And then because it's a bunch of steps on the GPU too. Because you're grading accumulating 32 times. Like 32 times the kernels that are launched.
Yeah. Yeah, no, I mean we gotta have a 7 dB soon. When is the deadline for 4 or 5?
I don't know, October.
Are you sure it's not sooner?
It should be October, yeah.
Yeah, I just don't know if it's. I'll check and post. I'm not
Alright, cool.
sure how late October it is. I know it's before, so that everything can be wrapped up before the holiday. Okay.
And then
I
ML
think try two GPUs, see if
yeah.
it shows anything.
And then ML training 6.0 results should release today. Be public today.
Great.
Great. Oh, which machine do you usually use to run these two? Does it only work for the MI350 or
Yeah,
MI300 also works?
I'm normally on AMD4.
Oh, can you disable the password or something? I can only connect to 4, but I always saw you're training wrong, so I cannot test stuff.
I don't understand why you can't connect to 3. I can connect to 3 fine.
Yeah,
Because
you
I
should have an
cannot
account.
connect to 3. I don't know either.
I'll look at that after.
Okay. And these won't work on MF300?
Not MXFP8. And not the flash tension either.
I see. Okay. Yeah. Okay, let's move on. Next is the Llama schedule stuff. I cannot hear you if you are trying to talk.
Kazal?
Okay. Mhm. Hello?
Hello, hello.
Yeah,
Yep,
works
we can
now.
hear.
All right, I switched my network. So I've been working on getting Llama to first match AMD. We are at 2 hours and 50 minutes. Last sprint, we were at 11,000 kernels. Now we're at 9,000. No new custom kernels added, just like I fixed Rangify to not make dump copies. We've got a few more to go, and then we should match their speed. I'm also mindful that you have the July event, so we want to make it a faster time.
Yeah, I think the July event would be a good time to show that off. If we could beat that, you know, we could just really talk about how our tooling has gone from our MLPerf submission down to you know, something that beats theirs. So is that are those kernels generic? The removal of those 2K?
Yep. So far you can read all my commits. They're like small scheduler bugs here and there.
Yeah, so a few of them. But cool. And you think the so how many is the AMD one?
AMD has 3,000. Yeah.
Are we gonna
I'll take
get that?
I'll take that with a grain of salt. So, though, like their RCCL kernel is a little weird. It's a persistent kernel that just stays on the GPU. But the main thing that we want to remove is 2,000 of the copy of the kernels that we have is just we're shrinking we're shrinking a tensor and then copying it, and that's creating a contiguous instead of
Yeah,
a
yeah.
subwoofer. Like that's just gonna go. That alone is gonna save 20% of the kernels total, not extra kernels total. So fixing that should be beneficial to everyone.
Great. Yeah, just make sure we have small small regression tests for each one of these things. Yeah, I know that's a known bug where if you shrink things, yeah, it'll make a copy. When in reality, it should just be copying from the subwoofer.
Yeah. Also, I've been looking into removing contiguous from custom kernel. It's a pain. It's a pain that it exists, and it's a pain to remove it. We should persist one of those.
Yeah, yeah. It's one of those things that every time I try to spend 20 minutes on it, I realize it's harder than 20 minutes, but I think it's worth it. I mean, it has to, there should not be user inserted contiguous as the custom kernels. Those should be inserted after the scheduler resolves things.
Correct. It's very bad because since the contiguous exists, call right now copies stuff, and it's not because like call is bad. It's because there was a substitute, and that substitute kept the contiguous around. So
I mean, you
it
can't
ends up having
remove,
a ripple effect. Yeah.
that's effectively a user contiguous, which you can't remove. Yeah, I mean, this just needs to be fixed. Do you think you have a good way to fix it? And
Spent a couple hours on it last week. Gets annoying.
it's
But
worth a couple days. Yeah, it's got to be fixed. I know it's not easy.
that's all I have. I have the full breakdown posted in the scheduler channel, so you can see exactly where we're spending kernel counts on.
Yeah. Cool. Yeah. The copies, those would be great to get rid of. Yeah, I mean the transposes, we just need to use the other gem kernel.
Transposes AMD also has
Cool. Yeah, but yeah, just the whole point of this project also is to continually improve the tooling. I think it's a good grind, and like the ultimate end goal. I mean, the thing in July is important, but the ultimate end goal is when we submit to MLPerf next. I want to have the best time for AP. Like, I don't think AMD is going to. Maybe they'll do a 4 or 5B on a huge number of machines. Who knows if that's comparable? But if we can just apples to apples beat them on 8B, this is really good. But cool. Yeah. So any other blockers? Anything you don't know how to move forward with, or you feel like it's just more grinding?
It's just a slog of scheduler bugs to fix. I tried a bit
Nope.
with GPT 5.5. It thrashes really badly. I wasted my weekend with GPT 5.5. It's very good at convincing you that it did the right thing, and then you look at the code and it's like
Claude's even better at gaslighting you.
it's like, yeah,
Did you try Fable at all?
nope.
Yeah, it's not that much better than GPT 5.5, if better at all.
I mean, it's very good at it was. I'm gonna be like fair with it. It was very good at finding the issues. Like I can give it the list trace and it like generates this. Like it's good at processing things. Once it starts to write code, oh god.
Yeah.
I basically hand wrote the gem fix that I merged today, one at a time, one painful line at a time, and then I gave it the example. It's like, now continue with this. Now it's better. At least it doesn't run in circles. But yeah, I think like the search space of possible ways you can get the custom kernels wrong is very large. Like you can just write very bad code. So it ends up creating things that mostly just nan the model instead of fixing anything.
Yeah. Yeah, no, I think we got to fix these fundamental scheduler bugs. GPT definitely is not going to fix them.
I'll continue working on that.
Cool.
Anything else?
That's all for me.
Okay. Next is my stuff. I think I'm one change away to remove cons unique. Still don't know too much about some of the qualify and function stuff. I have a PR that passed all the tests, and I still don't know if it will break llama or not. I really want to test this.
Which PR? Do you want me to look?
So it's basically instead of looking into using embedded clone for anonymous buffer and not.
Yeah, that behavior is not really used. If it works, then it works. Like whatever it is, it is.
The issue is I think part of the reason custom kernel is annoying is it's not very clearly spec'd. And because it's very flexible and just the different ways you can write custom kernels. I don't want to break llama, but I'm also trying very hard to test this.
Yeah, I mean, anonymous buffers just shouldn't be a thing. I mean, that thing that you want should be a function and not a call. Like if it's there should be no such thing as a call with anonymous buffers. This is why we have a distinction between function and call. Because an anonymous buffer effectively is something that's created inside of the function, and the function can return that buffer.
Yeah, so that's why my current change looks something like detect this pattern if it's only returned by the function.
Yeah, no, I see what you're doing here. I don't know. It's fine to get it merged. It's on me to make the spec cleaner. I have not. That spec is not correct yet.
Yeah,
The function call spec is not correct.
Yeah, so let's look parts. I'll find a way to test this on real llama training. Then if let's go, I'll probably merge this first. It at least gets the const source thing out. Then I also do several small change. Oh, I removed the unsafe pad thingy. So now add two pads invalid.
Wait. Oh, you switched pad to invalid?
Oh no, I switched pad to pad invalid. The optimization step.
Oh, okay. I see the like the beep search thing.
Optimization
Yeah.
action. Yes. So that is invalid now. So as a result, I remove the unsafe pad thing.
Great.
But yeah, that's a minor thing.
I mean, it's basically, yeah, we should just be able to switch all pads to invalid, right? Like right now,
so there's a difference between this optimization action to the other thing. For optimization steps, you don't want to skip doing ALU on that invalid, because that's the point of doing the optimization, to pad to a multiple of 4, for example, or pad to the size that you can do jam on. But the other pad to, say, the multi-case, I think you really want to skip those invalid and not being part of the compute.
yeah, I mean, but that's a different question, right? Like there's a question of like
I mean,
there's a question of what you want the range to be, but you never actually want to do the ALU. You always want to gate the ALU.
what do you mean by that?
Well, you never actually want to do the ALU on the invalid, right? The thing about the pad 2 optimization action is you want the thing to be rounded to something. But
okay.
The only reason you want it to be rounded to something is so you can do a further optimization action on that rounded thing. We can always remove all of the invalid ALUs.
Yeah, so if you want to round something to a multiple of 8, then do a jam on it. Then you need to rewrite that invalid to the actual number that jam would apply to.
Yeah, no, I mean, my point here is the distinction between these two things. It is the same thing, right? Like if I have something that I like, okay, the gem is 62 and I want to pad it to 64. And then I pad it to 64 and then I do upcast 8, right? And now that divides evenly and I have 8 and 8, right?
Yes.
The distinction in like the multi-case is I would pad that 62 to like 128, say, right? And if I pad it to 128 and then I upcast 8, I can upcast that 8 and still pull the invalid out of the first one as well. You see what I mean?
Following. So for the gem case,
yeah,
what I did was I replaced the invalid value to 0, so that those 0 flow into gem. And I think that's what you don't want to do for the multi-case.
Well,
but you need a value that you need a value that feed into the gem instruction, and that value needs to be 0.
Yeah. But we should, okay. The distinction between these things is if it's upcasted versus if it's globals. If it's upcasted, like, yeah, the thing actually is 8, right? Like the thing has a lane width of 8. You're not going to remove any of those 8. But if there's globals, there's a separate pass which does like range clamping, kind of like the thing that we do on pad.
That I understand. So my point is, all I did for the pad 2 optimization is for the local case, and I just replaced the invalid value to the identity with a rewrite rule. That's all what I did. I didn't touch the global thing, so that won't fully work for your multi-case.
It won't fully work for the multi-case yet, but yeah, we should change the semantics of pad. Like right now, there is code in Rangeify when it processes a pad that adds in a where. And that shouldn't be in Rangeify. That should be in mixins. That should be in pad itself.
Mhm.
Yeah, so I think that's the other things. Oh, do you have more?
Oh, I also fixed the comma image bug. There was a bug in Rangeify. There's
Yeah,
a rewrite rules that gives you half of a step, and it just happened to break if those half steps collide with each other.
I
So
saw that fix.
make it full.
It's hard for me to read. You mean the thing that does the like if there's two ends basically.
It's trying to use a range map to keep the state, but because each function has state, not complete state. So if you imagine if this rewrite rule is the other order, that every half step get complete first, then there won't be issue. But here the issue is two half steps parts, then their key collides, then the state got corrupted.
And maybe this is actually better than I thought it was, and maybe this code that I was complaining about is old.
Oh, I closed the bad one.
Yeah, I was like reading this. I'm rewriting the vectorizer, and I was reading this like thing that deals with those. I don't know. I'll have to find it, but
Okay.
yeah, maybe this is not the problem.
Yeah.
Oh, merge reduce ends.
I don't know what it is.
Yeah, it looks like you wrote it 2 months ago. There's code called merge reduce ends. Merge ends. It's in devectorizer.
That's something else. That's not listfix. Listfix is in Rangeify.
Yeah. Yeah. Okay. Yeah. That merge reduce ends needs to be deleted. Like it's a bug that it ever happens, basically.
Yeah. There was other issues for that.
But yeah, okay,
Yeah,
this is unrelated.
and I think finally your get item comment. Yeah, I have probably like 5 things I can clean up once PTR D type and back are gone, and I'll be happy to do those. Once
So PTR, D type, and VEC are already effectively gone. So you can pretend that they're gone everywhere. And yeah, so I already have this for you. So this is already all correct. So for VEC, you can look at the shape. So the shape always matches VEC even in the current implementation. And for PTR D type, so that it doesn't exactly work for the get item one. And I'm not exactly sure why, but like, so there is no more PTR D type. You have an address space. There's 4 address spaces: global, local, reg, and ALU. Global, local, and reg are all effectively what PTRD type used to be.
Okay.
Like they're all sort of pointers, right? And I made a distinction between reg and ALU because C makes this distinction. When you do something like float a sub 4, you can like a bracket 4. You can that's basically memory. Like there's no guarantee that that's anything else. But yeah, I mean, if you can change that thing, if you can look at, so you can also, the address space is now visible in Viz. It's it's in the upper right corner of each thing. Green is global, yellow is local, red's register, and gray is ALU. Yeah, so the get item cleanup, and then also we have stack and vectorize. These should be unified into one thing.
Yeah.
Yeah, I mean, it's kind of annoying. I mean, the whole get item thing should really become like, we should just not be afraid to just use index and shrink.
Yeah, I think we can decide this later. It's very similar to why don't you just use range or when you want to write a range and things like that.
I don't think that's true. The reason you don't use range when you want to write an A range is because that range is named. This seems
but
more
that
like,
seems to be a different issue, right? It's like you have this ops that gives you a range already, then why won't you like try to use that? It's similar to index.
well, but you should just be able to use index. And we should fix things so that you can just use index. You shouldn't be able to use range. Because range and A range are not the same thing.
Why not?
Because the shape's different, right? Like if you have like A range 100, the output shape of that tensor is 100. If you have range 100, the output shape of that range is scalar.
Don't know, but okay, this we can decide much later.
Sure, yeah, no, but we shouldn't be
Because
afraid to use.
we also have like examples that use something like that to construct your tensor, just call range and pretend it's a range.
There's ways you can do it, but yeah, this is I don't think they're the same thing. But my point is about the movement ops is like index and stack should be first class movement ops just like the others. We should be able to use them anywhere. We shouldn't like be like, oh, you can't use index here, or you can't use stack here. Like they're I made them the same color in Viz for a reason. They should be like the same tier movement ops.
Right. Sounds good. Let's quickly touch on your new style render.
Sure. Yeah, so I finally done. All the renderers now take in the new style API. I hacked it quite a bit for x86. x86 still uses pointer dtype and vec dtype everywhere, but most of the rest of them are pretty clean. And it uses it internally. So like the API from the output of code gen is no more pointer dtype and no more vec. I think everything's pretty clean. The most notable new thing that's been added is you can use shrink inside of programs. And if you think about it, right, that's really what it is. If you want to do like a load of a float 4, what's a shrink? You apply a shrink to the buffer, which shrinks it to the, whatever your starting point is, like an index. But then you have a length, which is 4. And that's just the second argument to shrink. So I think that's pretty clean. It required, a bit of changing to the way that like pad and shrink are specified, but I think that this new way to specify them now is very clean, and we no longer have to deal with things like if it's like end and begin, it's like, okay, well now I got to figure out, does end minus begin yield a constant after unsimplify on that? What if things are a little bit out of order? What if it can't simplify? So now it's just the offset, the shape, and that gives you that. The load, so that was the only thing that was really tricky, and that removes all of the casts. So we used to do cast. Cast used to be this overloaded thing that both meant d-type conversion, but also meant change the shape of a pointer. That's all gone. It's string. So that all works. Yeah, the next thing to do is rewriting the devectorizer and the expander to never use any of this vec, to never do pointer cat. All that stuff can be just deleted. Oh, JEP is deleted from renderers.
Yeah.
JEP is deleted from renderers. Oh, define local and define reg are deleted from renderers. Those are just buffer. So there's two ways to get buffers in a program. One is param and one is buffer. Param means it's bound to an external address, and buffer means it's internal. And I think that's pretty straightforward. And there is like a real distinction between param and buffer. Buffer is basically like, yeah, it's an anonymous buffer, and param is a name buffer. It's an anonymous buffer with scope of the function, whereas param is passed in from the outside, so the scope is external. But yeah, I think that's pretty clean now. There's no more, no define local, no define reg. In theory, you could imagine a buffer that's defined global. Right, the buffer address space can be global. That's totally fine. We can decide if we're going to actually be able to do that in the renderer, but it just means that that global is only scoped within that single function, and it can't be accessed externally.
Makes sense.
Yeah, so I'm pretty happy with it. It's slow, but we have a real spec now. We're working towards something. We won't have to hopefully redo this again. I look at this stuff, there's no real way to make it cleaner anymore.
We just need GPT-12.
No, it's like ideal. Like I think there's just not really a way. I think there's just like I've read all the different IRs now, LVM IR, NIR, and like I think that a
Yeah.
lot of the annoying things in those IRs don't exist in UOps, and there's nothing to take away anymore.
Great.
Yeah, versus the D-type thing needed to go, but yeah. Well, okay. There's still a few cleanup things, like barrier needs to go, but
Yeah. When I still had Fable, I have it to read a whole code base and read a whole spec and map all the things that doesn't the same. I have
yeah,
a big list of things to address.
nice. Yeah, Fable did after I did the first two ports, so I did the C style one and the LVM one. Fable managed to do the rest of them pretty nicely, except for x86.
Uh,
So yeah, hope we get it back soon.
Almost all the time. Fata, you want to share something?
No, not a whole lot. Just added those benchmarks and the fake data, so I can just quickly test the timing. I think we're just definitely over 24 hours. I think like 33 hours, but that's without Beam. So I think that's my next step, just taking a look into that and then fixing the tiny JIT issue on the eval step.
Sounds good. Yeah, I think once we have this trend, we should look into like why AM is not working, things like that. Maybe after HTQ2, we will know better.
Okay.
Okay, is Kama happy? I see another JIT.
Yes. So I have a PR open against OpenPilot to get them to latest TinyGrad. Had some like A range that was using device equals.
Okay.
So that wasn't just like a click merge, but I just need to bug them to make sure they actually get that merged.
Yeah.
But yes, they do have this other issue that Harold opened. I looked at it a little bit. I haven't looked at it in super close detail, but I think it has something to do the emulating D-type, emulating float 16 support because we round denormals to 0.
Yeah, is that
I guess
do you know if that issue is like a bug or is just numerical being very different, like slightly different?
it looks like it's just a numerical difference thing. Like basically when you do the rounding.
Can you look into that?
Yeah. Yeah, I don't know. I'll talk to them and see. Apparently, this is not a blocker for them, but it's just an
Yeah,
issue they encountered and had to work around.
you don't need to spend a lot of time on it, but I think it's a good idea to have a response to that. Just treat
Yeah,
Kama as
yeah.
a client, and we just
I'll
need to say if we are going to do anything or we are not going to do that, and you can deal with it.
yeah, for sure. No, I haven't taken. I like literally spent like maybe
Okay.
like a minute looking at it, so I don't know. I'm not
Okay.
entirely sure, but I will take a look a little bit more and see what's up.
Yep. We got a lot of first-time contributor just putting things in cloud. That's slightly annoying. Please don't do that. And I think those people are probably not in this meeting, so there's that. Okay. Anything else? Do we cover everything? Any closing words?
Wait, we can probably. Well, okay. I'll ask Harold if he can close the other issue that he has open that we think is fixed.
Okay. Oh, and we probably should also update the model to include their new release one.
They actually don't. There's a new DM model on 0.11.1, but there's no new model on, like, there's no new
Yeah,
driver
I
model.
mean, you just need to pin to whatever they release. It doesn't need to be a different model.
Sure. Yeah. I see what you mean. Yeah. Okay.
Anything else, George?
That's pretty much it. I think things are going. I think this will be the summer of spec tightening, and then when the summer's over, we'll have a very solid foundation where everything has a clear reason.
Great. Okay. That's it for this meeting. Thank you, everyone. See you next week. Bye-bye.
Bye.